Hello again, this is Mom Drea. Welcome to another discussion from the book of Management Information System by Kenneth and Jane Laudon. This chapter we're going to talk about internet. Well, congratulations if you're not listening to me using BMX or an old school DVD or CD. You are one of the 40% of the population who have an access to the internet. Well, unlike you, 4.3 billion of the population, whether it is from the first world or third world country, still can't afford or don't have an access to the internet. So the tech company like Google, Facebook, SpaceX are trying to bridge the gap and give us a free internet for the entire world.
Google's bid to bring internet to the world, dubbed Project Loon, is the closest initiative to being commercially deployed and has been in the works since as early as 2011 under Google's research and development company, X. As suggested by the name, Google wants to use high-altitude balloons to bring internet to the world. These balloons will operate in the stratosphere at altitudes varying between 18 to 25 kilometers. To bring connectivity to all the devices in a particular location, all that is required is one balloon to establish connection with a ground station, which then propagates through the balloon network. For example, a connection to a base station in the wealthier parts of Africa, such as Johannesburg, will be able to provide connection to the majority of Africa through the Loon network. To propagate the signal, the balloons, often a few hundred kilometers apart, aim precisely at each other through the use of laser technology. Then this signal can be sent to individual devices or even residences by connecting to Google's small cell device. Check out this demonstration from New Zealand to see the Loon in action.
I run a small farm. When I'm using the internet, the first thing I'll check is the weather, see if my sheep are going to dry out, and at the moment the wool's not dry. So I'm just looking for a window so I can plan my week. We've gone through a number of different internet providers to try and get reliable internet. It was so slow that we had to click on a page and go and find something to do for 10 minutes.
So can you give us a quick update on the launch?
Having a team from Google on our farm to trial this for the first time has been really exciting.
All right, coming out, 3, 2, 1. Straight up, straight up, straight up, straight up.
Starting today, we're launching a few dozen balloons so that 50 testers right here in the Christchurch area can get online through this experimental balloon network.
Bingo. Yay! And that was fast too. To be the first person to do that is a little bit cool as well.
Having access to the internet can change lives, and there are 5 billion people on the earth that aren't reached.
Speeds in 2013 ranged at only 1 to 2 megabits per second, and as of late range between 5 to 25 megabits per second, with generally 10 megabits per second stable. In other words, the speeds being achieved are top 3G speeds, or on the low end of 4G LTE speeds. As we'll explore later in this section, these speeds will continually improve in the future. The true beauty in Google's bid for bringing internet to the planet is its affordability and ease of deployment. Using their custom-built auto launchers, which are designed to safely and reliably launch balloons at scale, a new balloon could be added to the Loon network every 30 minutes. Recovery is as simple as coordinating a drop point in a sparsely populated location and releasing the gas keeping the balloon afloat. As of recently, sightings of the balloons are starting to increase, ranging from Canada, Sri Lanka, Brazil, Puerto Rico, and more. Additionally, Project Loon is demonstrating to the world how powerful a tool global connectivity is currently. Because of the Peru floods and the aftermath now, thousands are able to connect to the internet and send messages to family and friends while the balloons have been in the air, exemplifying that global connectivity will also play a critical role in disaster relief efforts in the future. Through additional partnerships with telecommunication providers, as well as Google's end goal to have thousands of balloons in the air by 2020, many will finally be able to access basic LTE speeds. These speeds will be life-changing to the majority of the world's population with only 2G speeds or no connection at all to the internet. Facebook's initiative to bring global internet connectivity is titled Project Aquila and has been in development since 2014. Aquila is a solar-powered drone and, like Google's Loons, will reside in the stratosphere between 18 to 28 kilometers. Aquila has the wingspan of a Boeing 737, 34 meters, and only weighs about 1,000 pounds, or the average weight of a grand piano. This lightweight is achieved due to the carbon fiber composite the craft is made from, which is 3 times as strong as steel and lighter than aluminum. Most of the weight comes from the high-energy batteries the drone has to carry, which also leads to issues of the load Aquila's flexible wings can support. During the day, Aquila will fly at 28 kilometers to maximize the amount of energy its solar cells can capture and store. At night, utilizing its lift-to-drag ratio due to its large wingspan and low weight, Aquila will gradually glide down to 18 kilometers due to gravitational potential energy. This will limit the amount of energy Aquila consumes at night at only 5,000 watts, or the energy of 3 hair dryers. Each drone will have an approximate coverage area between 4,500 to 7,500 square kilometers, providing speeds up to 10 gigabits per second due to the enhanced optical technology they will be using. The drones will also have the ability to propagate either LTE or Wi-Fi signals with upgradability in the future as networks demand. Recently, less than a year ago, Aquila had its first successful test flight. The original mission was meant to keep it aloft for 30 minutes, but it ended up staying up for 96 minutes to collect more data. It ended up crashing on its landing attempt as a wing snapped off due to a structural failure caused by winds faster than the prototype was designed to handle. However, it is to be noted that this result was expected by Facebook engineers. Facebook still has some ways to go before this technology can be commercially viable and economically feasible, with estimated deployment between 2020 to 2022. But once commercially deployed, it will be game-changing due to the high speeds and low latencies it will provide across the globe compared to other options for many people. With Google and Facebook being some of the largest technology companies on the market today, it's no surprise they're leading the charge on the race to global connectivity. Google wants to provide basic internet access across the world at scale, while Facebook's method, being more complex, is about bringing high-speed access to the world. Both Project Loon and Aquila will be essential in their own rights to bring connectivity to the planet and allow everyone to access the power and knowledge of the evolving web. It is also worth noting that as the years progress and 5G infrastructure starts deployment, that these initiatives, especially Facebook's, will see upgrades to technologies that can interface with 5G networks and improve speeds and latencies even further. While these Earth-based solutions will be great at providing connectivity in targeted locations, the next few initiatives we'll be discussing aim to bring connectivity wherever you are on the planet. The next few initiatives we'll be discussing are based in space, more specifically, low and mid-Earth orbit through the use of satellite constellations. To communicate to the ground, most of these initiatives will be using either the 12 to 18 GHz Ku, 26 to 40 GHz Ka, or 40 to 75 GHz V bands. These spectrums are classified as millimeter waves, and as the frequency the satellites use gets higher, it correlates to smaller antennas, equating to the ability to launch microsatellites. In the vacuum of space, communication using millimeter waves isn't an issue, but they are susceptible to attenuation by weather events and other obstacles once they enter the lower atmosphere. Back on topic, satellite constellations to provide internet connectivity may seem like a far-fetched idea, but the approach has been validated on the successes of 2 companies that have been working on the solution for a few years now, Iridium and Viasat. Viasat, instead of using a satellite constellation as an internet delivery method, uses just a single high-bandwidth satellite which can support many users, dubbed the Viasat-1, which was launched into orbit in 2011. This satellite is limited to coverage for just US consumers and has a bandwidth capacity of 140 gigabits per second, with the ability to support 1 million users at a time with speeds up to 25 megabits per second. This year, the Viasat-2 will be launched, preceded in 2020 by the launch of 2 Viasat-3s in partnership with Boeing. These satellites in orbit are aimed to provide global coverage with a capacity of 1 terabit per second, with speeds for individuals up to 100 megabits per second. Iridium has been launching satellite constellations to provide communication services since the late 90s, and is composed of 66 satellites participating in active global coverage. Currently, they are launching their newest constellation, the Iridium Next, which will provide speeds of 1.4 megabits per second for their target demographic of journalists, explorers, and military units. Both companies prove satellites as a means for global internet connectivity are possible, and if implemented properly, economically feasible. Through the use of single high-bandwidth satellites, Viasat can provide fast speeds, but has the downfall of less devices able to connect to the network. Inversely, through the use of satellite constellations, many devices can connect to the network, but speeds are much slower. The next few initiatives we'll be looking at are aimed at providing a solution to these issues, combining the best parts of these 2 initiatives.
Mentioned by the videos, this year is already 2020 and most of them is already economically feasible. Let's go now to these slides and topic. This is mostly examine what is internet. So can you describe now and what do you use it for? So mostly internet is the most expensive public communication system and the world's largest implementation for client-server computing, which we already discussed on our previous chapter. And you need a telecommunication service or the internet. You need the internet service provider, which is a commercial organization with a permanent connections to the internet that sells a temporary connections to the retail subscribers. So most of our homes and small businesses already connect to the internet by subscribing to an internet service provider like Smart, AT&T, Verizon's, so Globe, so PLDT. How do you connect to the internet? Do you use still a dial-up or a modem in your families? There are still a variety of services for ISP internet connections, connecting with our traditional telephone line and modem at a speed of 56 kilobits per second or kbps. PS. This is used to be the most common form of connection worldwide, but it has been largely now replaced by what we are now using broadband connections. So a digital subscriber line or the DSL technologies also operate over an existing telephone lines to carry voice, data, and video at a transmission rates ranging from 385 kbps or kilobits per second all the way to the 40 mbps, depending on the usage pattern and distance. The cable internet connections is uh, means it is provided by the cable television vendors use a digital cable coaxial lines, which will be illustrated later on, to deliver a high-speed internet access to homes and business. They can provide high-speed internet access to up to 50 Mbps, although most of the providers offer services ranging from 1 Mbps to 6 Mbps. So what do you use now? What Mbps are you using? Although now that we are on the quarantine situation, we are now grabbing all the bandwidths and we need all the speed for the internet connection. Some of you, do any of you use satellite as from our video? Note here that the T lines are leased or dedicated lines suitable for business or government agencies requiring high-speed quarantine service levels. You do know that the internet does not guarantee any service level, right? And it agrees only to make a best effort. It is possible to access the internet via satellite, although some of the satellite internet connections have been slower upload speeds than the other broadband services. So now we're going to talk next about IP address and what is it used for? Why do we have a domain name system? So the IP addresses. Every computer on the internet is assigned a unique internet protocol or IP address, which is currently a 32-bit number represented by the four strings of numbers ranging from 0 to 255 separated by periods. We discussed about the internet protocol or address before on our previous chapter, a little bit about it. So for instance, here the IP address is of Microsoft, www.microsoft.com is 207.46 250.119. Because it is incredibly difficult for the internet users to remember the strings of these 12 numbers, the domain name systems or DNS converts the names to converts domain names to IP address. Note that the domain name system makes it possible for us human being people to remember the addresses. It um, DNS also has a hierarchical structure and a top level domains, which we will be discussed on our next slide. So here is the hierarchical system with a root domain, top level domain, second level domains, and a host at a third level. The root domain is the period that is used before the top level domain, such as edu.edu or .com. Example or internet address, which is .edu, ednu.edu.ph.com. So the second level um, the second level domains have two parts. This designation, a top level name and the second level name, such as buy.com or nyu.edu, or adnu.edu or amazon.ca. So a host name at the bottom of the hierarchy designates this specific computer on either of the internet or the private network. Here we have sales.google.com. So the sales is the host name. So the countries also have domain names such as us.ph in the Philippines, .uk or .au for Australia and other countries. There is a new class of like an internationalized top level domains that use non-English characters from ICANN, which is the law for this. In the future, this list will expand to include many more types of organizations and industries. For .com, it means commercial organizations or business, right? For .edu, it means educational institutions. We know that if there is a .gov, it is used for government agencies. And .org for the nonprofit organizations and foundations. What else? .info for the information providers. Um, we did a video or case study which is reported by Celine and Tero in our class, which discussed on the net neutrality. So as we mentioned before, for analogies, we can compare it to like toll highways versus the freeways, or peak time pricing for the electricity. So I have a question. Should the trucks be charged at a higher fee for the use of highways than the small autos because they cause greater wear and tear on the roads or on the highways or freeways given their weight? So in some places they have higher trucks pay much toll fees due to these destructive effects on the highways. So internet data traffic is carried over the trans continental high-speed backbones. network that generally operate in the range of like 45 Mbps to 2.5 gig Gbps. So these trunk lines are typically owned by long distance telephone companies, code network service providers, or by the national government's local connection lines are provided by the regional telephone and cable televisions. Um, it it also connect the users, us, the retail users in homes and businesses to the internet. So the regional network is like leasing the access to ISPs, private companies, and government institutions. So each organization pays for its own networks and its own local internet connection services, as part of which is paid to the long distance trunk line owners. So the individual internet users, us, we pay for the ISPs for using their services, and they generally pay a flat subscription fee. So no matter how much or how little they use the internet, no one really owns the internet, and it has no formal management. So the debate is now raging on whether this arrangement should continue or whether heavy internet users who download large video and music files, TikTok, and other streamlining should pay more for the bandwidth they consume. Let's now talk about the internet services. What are those? Can you give me one? We have the email, which is the person to person messaging, documents sharing. We also have the chatting, uh, instant messaging. We have discussion board or like our bulletin boards. The file transfer protocol for transferring files from computer to computer, and the World Wide Web, which is the retrieving, formatting, and displaying of information, including text, audio, and graphic and video using the hyperlinks. So we just continue to discuss about what the internet is. Here we are looking at the services or applications that the internet supports. You notice that the internet comprise many more services than just email and the web. So which of these services beyond email and the World Wide Web, www, have you used, or and can you are you able to like describe it? So we now go to client server computing on the internet. We know that the emails messages enables us to exchange messages from computer to computer with the capabilities of routing messages to multiple recipients, forwarding messages, and attaching text documents or multimedia files to messages. So most of the email today is sent through the internet. And here we can see in the illustration the looks at the services that the internet server provider can offer. The website, HTTP, the email or the simple mail transfer protocol, the file transfer protocol or FTP, the news group for the NNTP, and this illustrate where on the path between the client and the back-end service, back-end systems these service files. So we can know that it sometimes have to go to the web pages illustrated by the application server. Uh, let's go now to the voice over IP or the VoIP technology, which delivers voice information in digital form using packet switching, avoiding the tolls charged by the local and long distance telephone networks. So some of you may have cable internet telephones that are using VoIP. Other popular technologies that use the internet as a platform are VoIP, like Altura, Skype, Google Net Meeting, cable providers, and other. The unified communications and the virtual private network or VPN. Uh, what do you think the value for this to the business? So let's look at some of the illustrations for the VoIP. This one shows how VoIP works. The voice messages are digitized and transported over the internet in the same packet switching method as traditional internet data. The gateways are simply computer network devices that maintains the interface with the internet in a firm.
Video, I'm going to give you
Hold on.
how it basically works and why it should be important to you. Voice over IP, also known as VoIP for short, is taking telephone conversations, routing them through a phone over a network cable into the network and then out to the internet. So instead of using the traditional phone network, which was made up of copper wires and central offices and telephone poles, now we've taken the entire phone communication concept and moved it over to the network. So when I make a phone call, what's happening is
Thank you for calling the Academy of Organized Crime in Chicago, Illinois.
is that the conversation is being routed over the network. How does it do that? The way it does that is that the microphone and receiver in here are working a lot like the same way that your iPod might work or your MP3 player. It's taking the sound and converting it into little bitty messages, or you can almost think of them as like little bitty MP3 files, although they're not MP3 files, they're packets. Taking those little bitty recorded sounds, actually like several times a second, sending them over the network as network packets, no different than like email or web content. And then at the far end, the other phone is opening up those little messages or those little packets and playing that sound back to you. So when you speak, it's being recorded as a digital conversation, little bitty packets of recorded information going through the network. And when you hear, what's happening is the phone is receiving those little bitty packets of information and playing them back to you. Now, why should this matter? Well, the reason it should matter is because, like it or not, this is the direction that the future of telecommunications is going. The old copper plant and even some of the other digital mediums like T1, they're going away because of cost. It is way cheaper. Let me give you an example. If I were to take this phone that was on a traditional network, so assuming I was on the old-fashioned Ma Bell network or MCI or Sprint or whatever, if I made a phone call, say, to Japan, it's probably going to run me somewhere between, maybe 15 to maybe as much as 40 cents a minute. If I were to make that same phone call using voice over IP, it's probably going to cost me about 2 cents a minute. All right, so that's one of the reasons that's driving this rapid change over to voice over IP. And voice over IP kind of comes in two different flavors right now. There's premises-based systems, which means that all the equipment to run your voice over IP phone system would actually live on your premises, like in your building. But there's also cloud-based. What cloud-based means is that all you need is a switch and the phone equipment. You don't need to have any kind of centralized brain or PBX stored on your location, because all the signaling, decision-making, routing, processing, that's all happening in the cloud or happening in these data centers that are hosted by these big name cloud PBX providers. All right.
Other popular technologies that use the internet, we have the unified communication, which integrates the disparate channels for voice communications, data communications, instant messaging, email, and electronic conferencing into a single experience where the users can seamlessly switch back and forth between the different communication modes. The present technology shows whether a person is available to receive a call. So this is level up of the voice over IP and the combination of all the this system or integration of all the system. The virtual private network, we discussed it on, I think, chapter 4. This one is secured, encrypted, the private network that run over the internet. Example, the PPTP and the channeling. So that ends our discussion for the global internet and the internet services. We are going to go deeper. The next topic will be the web. So I will have to cut this short so that we